Okay, so the left will have your input. The right side will be the output. Okay. And in between, we have a rule. And you can see our rule is 2 times x. So if x goes in, the output would be, we say this one of 2 ways. Function of x, or more commonly, f of x. F of x. Again, does this mean f times x?
No.
Never. This means the function of x, or f of x. Okay? So the output would be the function of x. But if we put in 5, and it's 2 times x, and x is 5, then this would be 10. It's 2 times whatever x is, and if x is 5, here, if our input is -3, we would get -6. It's just 2 times -3. All right. So let's do something a little more substantial here, guys. Here's our input. Let's get some outputs. So the rule, here's our rule. The rule is this. If x goes in, it's going to be x squared, x to the second power, and then you add 1. Okay? So let's see what we get. And that would be our output. So we're going to replace x with 5. So how much is 5 squared? 25. And then you add 1.
22.
We'll get 26. Okay? Let's see what we get in this case. We're going to square -3.
9.
You get +9. Negative times a negative is positive. You add 1 to that, you get
10.
10. A big part of what we're going to be doing is stuff like that. Okay? Now, let's get into what a function notation is. So, except for maybe geometry, and even maybe it'll creep in a little bit in geometry, pretty much from now on, algebra 2, pre-calculus, calculus for sure, you're going to have this type of writing or this way of describing a function. Okay, so let's talk about function notation. So basically, this is a way of describing a function. Here is the key, and they didn't include it here, and I wish they would have. Let's write this. Okay, go ahead and write this down. This is kind of, by the time you get to calculus, it'll be more advanced and you'll understand it better. But for our purposes right now, think of this f of x as like your y variable. think of it as identical to the y variable. So they can interchange. Wherever you see the y variable, you could put f of x. And wherever you see f of x, you could replace it with a y variable. They're going to have the same purpose, okay? All right. Now, so normally we name it something. In this case, f for function. That's the most common name, but it's not the only one. We could use other common names are g of x, h of x, k of x. So it's not always an f, but that's the most common one. Okay, so the name is whatever letter is in front, usually f, but again, g, h, k for some reason gets used a lot. So we would say this is read as f of x or function of x. Okay. And like I said, is equal to which variable? Y. So this is equal to y. Wherever you see it, basically that's it. And the cool thing is, one of the main reasons it's written like this f of x notation, this format, is it tells you what the input is. The input is whatever number is in here. So an x is the input. Because it's not always going to be x. I mean, that's the most common one, but not always. Okay? So this is just another way of writing an equation, but when you write it this way, we know it's a function. It's guaranteed to be a function. No ifs, ands, or buts about it. So let's take these original rules, right? And let's write them as functions. All right. So you guys ready? So I need you focused here. Let's take this rule and write it as a function. This is how you would write it. You would start f of x equals, and then whatever the rule is. So this would be the rule. F of x equals 2 times x. Okay? Let's write the second rule as a function. Let's stick with f of x, because that's what they told us to use here. So this would be f of x. And now we're looking at b. What's the rule there?
X squared plus 1.
X squared plus 1. We just wrote two functions. Okay? Now, like I said, the main thing we're going to be doing is evaluating these. Evaluating is just finding a number answer. So we're going to evaluate a couple of these. Let's do it. Okay. So we have 1, 2, 3, 3 functions, and then we're going to evaluate them with f of 4, f of negative 6. So the cool thing about functions, written this way, it tells you what to input. So here we have our function, f of x equals 6 times the quantity x plus 9, right? What is my input for a? 4. The input is 4. Let's see what the output is. And the way we figure that out is we replace x with whatever the number is. So I'm going to do that. So the rule is 6 parentheses x, but instead of x, I'm going to write 4 plus 9. And then let's see what that gives us. So it's going to be 6 plus 13. And now all we have to do is say, well, that's what? 78. See how easy that is? Yes.
we skipping the evaluating functions part?
Oh, I jumped the gun. Let's just go ahead and write that in. So to evaluate f of x for x, substitute 5 for the variable x. And so basically this is what we've already done. And let's see, that would be 24. So we substitute the variable, in this case x, with a number for the input. Okay. Yes. Yes. Oh, it's right here. It's the input. Well, they tell you figure out what happens when x is 4. Like here they're asking figure out what happens when x is -6. So they'll tell us. Okay. So we're going to evaluate this function when x is -6. So let's do the same thing. 6 parentheses, instead of x we put -6, then +9. Let's see what that gives us. So that's going to be what, 3? So it's 6 times 3, 18. Okay. There we go. So let's see. On the next function, notice on this one they're not calling it f, it's g of x. So that's another g, p, x, just depends. So they're asking us to, in this function, evaluate it when x is 1. Yeah, so what we'll do is we'll replace x with 1. And then they're asking us to square it. And then take away 12. So I'm replacing x with 1. So 1 squared is 1. And then take away 12. -11. So let's see what happens when x is -3. So the input this time is -3. And then we'll square it and then take away 12. Let's see what that'll give us. So -3 squared is +9. And then take away 12. So we'll get -3. Okay. All right. So the next function is p of x. So the input is 8. So this one wants us to 8 minus x and then divide by x. That's interesting. So 8 subtract -8. And then divide by -8. Let's see what that gives us. Yeah, 8 minus -8. Yeah, that'll be 16. It's 8 plus 8. Remember, you do keep change opposite. So you get 16 divided by -8. We get -2. Okay. So try the next one on your own. 8, subtract 8, and then divide by 8. What do we get? Hopefully you're saying 0, which I'm hearing murmurs of that. Yeah. Okay. All right. So for P of x in question 3, is there a value of x where the function cannot be evaluated? In other words, is there some number I can have for x where we wouldn't get an answer? Think about that. Yes. Yeah, if 0 is in the denominator. So what number for x would make 0 the denominator? 0. Because if we use 0, then 0 is a denominator, and we cannot divide by 0. So it's undefined there. So that's we need to say that. So first of all, let's answer the question. The answer is yes, there is. If x equals 0, because you cannot divide by 0. And once you get into like calculus and pre-calculus, when you're graphing stuff and you wind up with a 0 like that in the denominator, funny stuff happens to the graph. Let's say it's undefined. It's undefined. Okay. So it's undefined. That's kind of. Okay, ready? Gonna go on to this side. So let's evaluate a few more functions. So let's find f of 3. So we want 1/2 times 3 minus 6, and then minus 5/2. So let's see what that gives us. 3 minus 6 is what? Negative 3. And then we multiply negative 3 times 1/2. So we'll write that as negative 3/2. Negative 3/2 minus 5/2. And simplify negative 8/2. So in the end, it all turns into negative 4. Okay. So let's find h of x when x is negative 5. Let's evaluate it when we have negative 5 for x rather.
So 5, and then we have negative 5 plus 3, and then square it. So all of this is based on your ability to do order of operations. Parentheses. So we got 5 times negative 2. Then we square that. So that would be negative 2 squared is 4. And that's finally going to give us 20. Okay. Let's do g of x. And the input is negative 7. Okay, so the input is negative 7. Let's plug it in. 3 times negative 7 squared. Notice I put parentheses around it. I don't want to make any mistakes. I'm being as careful as possible. Okay, so I plugged everything in. What's my first move? In the parentheses, and then within the parentheses, I better do the exponent first. So negative 7 squared is 49. It's negative 7 times negative 7, so we'll have 49 plus 1, and then plus 7. Oh, minus 1. Sorry about that. Minus 1. Okay, so that's 48. 3 times 48, and then plus 7. Okay, and so that's going to be 3 times 48. 100 and 144, and then you add 7, you get 151. Okay. All right. I want to move on to this one. Oh wait. Oh no, that's the one. Yeah, let's continue to 7. Okay. So it says given the function f of x equals x squared plus 10, what values of x would yield negative outputs? So take a look at this. F of x, what's the rule? X squared plus 10. Look at the rule, x squared plus 10. You take a number, you square it, then you add 10 to it. What would give us a negative?
You can multiply a negative.
I think because if you were to have a negative, multiply by a negative, it would become positive.
Yeah. I was onto something. You square a negative number, doesn't it become positive?
Yeah.
And if you add 10 to it, will it ever make a negative? No.
It has to be a negative that's great.
It would have to be an imaginary number, right? So there, I guess we could say there's no real number, and you guys don't know about imaginary numbers yet, and so those numbers aren't even on our number line, so it's not even a number that exists in what we normally do. So yeah, we could say there are no real numbers that would produce a negative number? Would have a negative output. Okay. Lino. Ooh, I used to have an uncle named Lino. He passed away, unfortunately. Yes.
It's like a random question, but why whenever we're writing in like sentences and just like in general, we always say real numbers?
Mm-hmm.
Are there like numbers that we don't know
Yeah, I did mention negative number or imaginary numbers. So there's two number lines. Okay. There's the real number line, and this will be real quick. So that's all the numbers you know of. And everything in between, right? This is the real number line. There's another number line, and we'll just write it this way. This is called the imaginary number line. And I, 2I, 3I. That I stands for imaginary number. And then you could have negative I, negative 2I, negative 3I. This number line does not exist anywhere on this. The only number they have in common is 0. Okay? And this is, if you square these numbers, you get a negative. So, that's actually the definition. I squared equals negative 1. Yeah, it's when you get into algebra 2, you'll get into why that works and what it's all about.
But then in that case, then even still, there's no possible solution to that. It's like
Unless it's no real numbers. Those are imaginary.
That's why
Yeah. They're not on the real number line. So that's why we have to say no real numbers. There are numbers that would give you negative answers, but they're on. You would do another number. You would do something bigger. So you would square like 5i. That would give you negative 25. Plus 10 would be negative 15. So there are numbers on the imaginary number line that would work to give you that answer. Good question. All right, guys. So Lino here plugged in negative 9. Look at the mistake. See if you can catch the mistake. The original rule or function is 18 times 2 minus x. And he's plugging in negative 9. And he says negative 26. Hold on. He got negative 126. Jesse, tell us.
You put a 9 instead of negative 9?
Yeah, that's a common mistake. That's why I'm always using parentheses. Yeah, he put in a 9. Do you see it right there? Because that minus is this minus. That minus is this minus. So he actually plugged in 9 instead of negative 9. Okay? And so okay, and the answer should have been 198. 198. I'll just give you that because I want to go on to this graph. Okay, so let's take a look at number 9. So here is the graph. If you ever wanted to know the graph of f of x. Okay, so here's the graph. Let's find out when f is -4. f of -4. So remember, what is this number inside? What number is that? What do we call that? Our input. So it's your x. Go to where x is -4. X is -4 right there. What's the value for y at that point? So you go where x is -4. You go up to the graph and go across and figure out what y is. That's your output. Okay. All right. So I just wanted to get to that graph at least. I think we're good with the notes. We've covered a lot. Let's do some work. So the assignment is on Delta Math.